Hi everyone. So let's continue our discussion on lines. So let's say that you're preparing something in the kitchen and you observe how the temperature is changing with time. So let's say that you've got some thermometer in here and you're looking at a watch. After 10 minutes, you register the temperature to be 140 degrees Celsius. Also, you realize that the temperature is raising 10 degrees per minute. So at each minute, it's raising by 10 degrees. Now, you could plot that information in a graph. So let's say that our y-axis is the temperature and our x-axis is time. You've got your point, 140 and 10, and also your slope, which is 10 degrees every minute. And there you go. So there would be two ways for you to describe this line. One is called the point gradient form, and it's given by y equals y1 equal to mx minus x1. x1 and y1 here are the coordinates of any point you know. In this case, those ones here. So this would be an x1 and this temperature would be a y1. So applying to this example, our equation of the line would be y minus y1, which is 140. This should be equal to m is our gradient, which is 10 multiplied by x minus x1. So this function here is assuming y in temperatures in degrees and x times time in minutes. Another way to describe a line is called the general form or the standard form. And in this case, you have ax plus by plus c is equal to 0. And a, b, and c here are constants, so any real numbers. We may develop this equation, the same equation of a line of this example, to get the standard form. All we have to do is expand the right hand side and join the numbers. So we would get y minus 140. Here that's 10x. To the left, negative 10x minus 100. To the left hand side, plus is equal to 0. Now we can work those numbers here, so we'll get minus 40. So y minus 10x minus 40 is equal to 0. This would be the standard form or the general form for this line. A few cases worth mentioning here are for constants. So let's say that you've got a horizontal line which is constant. If you notice, all the heights are the same for any x. So this line is described by y is equal to c, where c is a constant. This could be viewed as the standard form in which a and b are 0. Well, in fact, b is 1, right, and a is 0, so it doesn't matter. The x, y will always be the same. Now, another particular situation we may find is a vertical line. So in the case of a vertical line, x is the same. So x is a constant here. And for any of those cases, c is a real number, right? Notice that those are, for example, in this one, b is equal to 0, and in this one, a is equal to 0 in your general form. One last thing we may grasp from this example is the gradient, because if we observe, the gradient means a rate of change. So when we have examples in which it's just y and x, that's fine. It's harder for us to visualize this. But in cases such as this one, in which y is something like a temperature and x time, the gradient actually means something. So in this case, since y is temperature and x is time, the gradient will give you the rate of change of the temperature in respect with time. This is very similar to something we'll discuss when we get to calculus, which will be a mathematical procedure, but so far just understanding rate of change, the gradient as a rate of change, is a very powerful tool already for us to solve lots of different problems and modeling lots of different issues as well for us to solve using those equations. So in the previous example, we had this final version of our equation of a line. Again, this is what we call the standard form or the general form. But there's another way, which is far way more common, which is the gradient intercept form. Gradient intercept form, and it's simply y equals mx plus k. And again, m here is our gradient, so it's a constant, and also k here is another constant. Both are real numbers. It's important to notice here that k is a very special character. It's called the Y-intercept, and it tells you when, or more precisely where, will this graph intercept the y-axis. So it's expected, right? Because this is x is equal to 0. So if you put x equal to 0 in the equation of your line, you should get y equals k. But nevertheless, it's a very important feature that you should never forget. In this example here, our gradient intercept form would be, we just get those guys back to the right, 10x plus 40. So if our question was, in the previous example, what was the initial temperature of the oven? And this would be the initial temperature. This would be our y-intercept here. Or let's say that we're given this equation. If we are asked, what is the rate of increase of the temperature in respect to time in the oven? This is the answer, 10 degrees Celsius per minute. And that's exactly the gradient. So after a minute, we would predict our temperature to be 50. After another minute, 60, and so on.